record. The meeting is going to be recorded. So this is fine. Okay, so this is officially starting time for our class. That was just really testing what we can do for the quizzes. So one more time, if you just joined to this meeting, everything is going to be on our Blackboard on weekly base, which was on course content. And then since we are already in week number 10, and then we have a midterm, so then on week number 10, we have several links available for us, right? So this is just GrooveWorks, which is what is today, which is 23rd, right? So for 23rd, we have GrooveWorks number 12, and then GrooveWorks number 13. And then we have a midterm, and then we have the quiz for today, right? So for the quiz for today, if you click on that, it's really like any of your GrooveWorks that you have done by now. And then it says the due date is after your class time, which is just really giving you half an hour to do and scan it. And then for the midterm, instruction says, please make sure you have all access to my MATLAB, okay? So as you see over here, it says there are 2 tests set to be for your test, okay? So one of them is, if you write something on chat, I need to read, sorry if sometimes I stop because I just need to read what you said. So for now, it says you have 18 problems, right? And then for chapter 4 is 100 minutes test, and for chapter 5 is a 30 minutes test. And then this is going to be 50% of your job. I will make it available on Wednesday afternoon by Thursday afternoon. So means you have a total of 24 hours to find a quiet area to do the test. So this is a total of 100 and then plus 30, so 130 minutes test. You don't have to do all 2 tests at the same time. But you have to finish it at once, okay? So it says there are 2 submissions allowed, means you can just try it, and then you can, if you reopen the test, is just really change the problems one more time, and that's just really to try, okay? It's not like assignment, you have per question, you can try it 5 times and then put the wrong number, and then after 5th time it block you out. So it's just really the entire test. You can do 2 submissions. If you do 1, press on submit the test, then the next one is really your last chance to submit your test, because the reason is because you see the problems already. That means you have no chance to redo the test again. So that's just really main thing that you need to know. I'm thinking about why I put the problems you can discuss with your friends, because this is naturally what's happening for students. If you have any friend in your class or somewhere else, you will ask questions from your friends, okay? So you may ask something that is really regarding the test. I don't want you feel guilty about just talking to your friends about the test, but make sure at the end you can't copy the problems from your whatever is your resources. So you have to have your own word of writing steps and everything for me in a separate paper, okay? We have done this 1 year for all assignments. So then this is just really what you have done for your assignment to get the extra credit. You see the problem, you do your problem on the test, and then you keep in a just really separate paper what are the steps to get the last solutions. So if you submit the test on online platform on my MATLAB, that's just your 50% of your job. The other 50% is when you write down your work and upload it on this link here on Blackboard for me, like really what you have done for your extra credit of your assignment. Keep your work and show me your work to get the other 50%, okay? So there are total of 26 problems, and then for that working thing, you have the due day for that paperwork, you have the due day by midnight of the Thursday, but for the online one, it's just really 4 p.m. to 4 p.m. So you start on 25th, 4 p.m. end by 26 4 p.m. and there is no extension. I think 24 hours has the total enough time for all of you to find a just really a place to do it. So if someone is busy in the afternoon, can do it in midnight. Some midnight is not working, so morning not working, the other day afternoon. So I think it's just really plenty of time for you to just find the just really concentration somewhere to do the problems. Okay, and then this is total of 50% on my MATLAB, 50% on just your paperwork that you uploaded online, and that's it. Is there any question about this instruction? Anything? So I think somebody wrote something on chat. If I'm writing, no, nothing. Any question about this? Okay, there are two parts. One part is on my MATLAB. You click on submit and you submit. The other part is on Blackboard, which you need to upload your work, the steps, before getting to that one. It has to be the same way that you do in these. The time that will be available on my MATLAB, as I said, is the test on my MATLAB will be available at 4 p.m. of 25th, Wednesday, and it will be end by 4 p.m. of 26th on Thursday. And then how did the problem more similar what to do in the class, or the more comparable with the problem on my MATLAB? I think it's just really similar, right? Because we don't do anything out of the book. It's just everything is coming from the combination of our classwork and my MATLAB works. And that's not really the solution for doing the test in entire semester, right? So this is just for this test, okay? So for this test, it seems it's all take-home test, right? And then we are practicing the quizzes to do during the class time on Blackboard, okay? So again, this is not really the decision for entire semester. We might change it for next time. Yes. Any other question here? The questions of the test will be available on my MATLAB. So you do your job on my MATLAB, complete on what is 26 at 4 p.m. And then you have about 6 more hours by 12. So it's just 8 more hours, okay, to write down and then upload your paperwork for me on the Blackboard. So it's 50-50. So you see your problem, you do your problem, you submit it on my MATLAB, but you need to keep the work that you have done before getting that solution on different paper and scan it and upload it on Blackboard. You have about 8 more hours to do that scan after finishing the test. Yes, exactly. That's the setting for the test on my MATLAB. When you have started the test, it says 100 minutes to finish the test. And that's it. You can't, it's not like assignment, leave it and then come back whenever you want. So it's just the test. Test is like that. Any other question here? Any other question? Sure, move on. So as you see on the schedule, so we have planned for today Just, I mean, for this week, entire this week, the plan is just doing 4 sections as much as we can. So the first one is just really a short introduction why we need to study the differential equation. There are several applications, I think 3 or 4 applications in this part of our class. And then we try to do 3 different types of differential equation. One is separable, the other one is linear. And then 3.2 is another application, which is very common application here. In differential equation is traditionally here. It's just really related to 2.3, okay? So the plan for this week, as you see, is just really to cover 4 sections. So I will use the time of the class always to do the lecture, unless you have any questions. So obviously I will answer your questions first, and then I will continue the what is it, the lecture. So then if you have again, if you look at to the files, I think I just have every solutions available for you by now. So you see you have all your group works available for this lecture. I think you need from 5 to 12, sorry. So for this test, you need to practice the group work from 5 to 12. And then I have all the quizzes as of now. So we have had 7 quizzes, so the solutions are there. So this is for the quizzes. And then I have whatever we do during this meeting, and then I do it on OneNote. I just make it on lecture note. So this is just the top one is the blank one, the one that we started without any note or solution. But the bottom one is the one that we do it through the Zoom. Okay, so this is just really what you have on these files. And then for recorded video, it's just really as I said last time, don't count on this recorded video, but that's just really the process, because most of the time it takes about 1 day for I don't know, the system or Zoom to post or to complete this recorded one to send it to me. So for example, I've done one meeting on 17, I mean one class on 17, March 17, but I got it on 20th. So for some reason it's super slow. So don't count on this recorded one. You must be here on time as you've been for any class time, and then listen to me. But as soon as this recorded one is available, I will post it on this link. Okay, so you just need to click on that. It send it you on the YouTube. Is really basic, is really what we have done during the class. So for for us, it seems we have only 1 class as of now. So that's just really saying your class name, and then which date, which was 18, we have recorded. Okay, so again, don't count on this. I will send it as soon as I get it, but that's just really depend on what the system is doing, and because it's just really heavy when it's 2 hours or 1 hour and 50 minutes, so I get it really late. Okay, so then whatever is really needed for this course is right there to study. And then so again, the plan for this week was right in week number 10 to cover what is it, 4 sections. And then we have had 1 group work due tonight, and then we have 1 more on 25th. Okay, any question about any of these assignments, anything? I was looking to the discussion board as you have posted some questions. I think it wasn't really any question or concern about the course. So if I go back to the discussion board and see what was the question. So flex, yeah, it seems everything is easy in this part. Yes, it is. Yeah, so this part of our course, which is the differential equation, is a lot easier than the first part. Is just because it's application, because it's something that you've seen it somewhere or you will see it again, so you like it, I will say, more, because it's more calculation than the abstract part that we have had. Do we have any connection? So the other question was, do we have any connection between what we are learning right now as differential equation and what we have learned in linear algebra? Yes, that's the goal of the course. So first we have learned about the linear algebra, which is the matrices and the algebra on matrices, and then we have differential equation, and then in chapter 9 is just really what is the connection, or how do we use the linear algebra to solve the differential equation. That's on chapter 9, which is the last chapter. And this is it, right? So I don't have any. Thank you for putting the comments. Keep going to that discussion board. Then that's just really any other question here? If I have one more from Nicole. Yeah, so Nicole asking about the graphing. Yeah, that's a problem. The graphing of something that I have made last time was what was it? The hyperbola. I have had hyperbola for the graphing, and that's just really one single chapter of algebra. If we can go back to the single chapter of algebra and just study what we call conic sections, and that's all really what we need. So hyperbola, parabola, circles, and that's it, right? Ellipse, sorry, 4 of them. So you can just really go back. If it's hard for you to find in your algebra what are those conic sections, I can post a little note or just cheat sheet or however you want to call it for conic sections, but that's just how much of graphing you need from algebra for this course. Any other question? So that was on your discussion board, week number 9, and then I have made everything available for just that discussion board again. Any other question here? Do you see that that's extra credit homework? So do you see that's just really 2 chapters? So for maybe if you have had planned to get that extra credit, if you have done it on just iPad or like me on Surface Pro, it's easy for you to upload over there. So that's perfect. But if you don't have any scanner, or it's hard for you to scan maybe 50 pages, 55 pages, because that's just a lot of work. That when you have the I think how many 6 sections of chapter 4 and then chapter 5. So if you do not have time, we are getting to the spring break, so you will find free time. But if you think this is a wasting time to scan all your pages of your homeworks for some reason, and it's hard for you to upload over here, don't worry, just email me. I need a personal Zoom meeting to get the extra credit for homework, okay? So just email me if you don't have time or you don't like to scan all extra credit pages of your homework, and then we will set a meeting individually for you, and then you'll just show me in the camera, okay, I've done this problems, I've done this type of the work, and that's it. If it's easier for you to scan how many pages you have, that's perfect. If it's easier to show me through the Zoom meeting, request individual Zoom meeting, and then we can just talk about whatever else, okay? So for anything else, you can always request through the email, I need individual Zoom meeting. And that's just really like office hours. I can just make the Zoom meeting. Is that fine? Any question? So in order to know what's going on this course, all I need to do, go to the course content, weekly base, and click on that, okay? And Joel is the one that is responsible to email me if something is odd about the due dates, okay? So then I can fix it. Do I? As I said, I will have a Zoom meeting every single time is the class time, and I will teach during that time. Yes, we do have a Zoom meeting, and that's the teaching time. We need to use every single minute, okay? Any other question? Okay, let's move on. This is what you have online for the lecture note of what is motion in a motion for falling body. That's just really very blank, and that's because it's all about the steps that we have seen. I mean, it's just somehow you have seen what do we call the second law of Newton's, and you know m times a equals force, right? So this is just really what we've seen it before, is just really bring it to the differential equation if you haven't seen that differential equation, okay? So this is just to remind us whatever we are learning over here in differential equation is all applications in physics, in statistics, everywhere. There are thousands of the applications of differential equation, even if it's as simple as linear first order differential equation, okay? So this is simply without knowing how to solve differential equation. That's just one of the applications that we can do by simply the concept of derivative, simply the concept of integration, and you can do the integration. This is a short introduction to tell us there are thousands of the applications, and that's one of them that we've seen it, but we haven't noticed in this way of solving the differential equation, okay? Ready? So this can be bigger like this. And then, so what do we call second law of Newton's? So that was m times a equals f, right? So the force is m times acceleration. And then what we have learned in all of the calculus classes, the acceleration is the derivative of, the first derivative of the acceleration is the first derivative of the velocity. And then if there was no air resistance, so then the force was m times gravity, m times g, right? So then if there was any, in this case, this is going to be m times g, but if there was any air resistance, and then I'm going to call it something else, f sub 1. So that's just really something, we call it constant times the velocity, okay? So that constant is just really something that depends on how, so this is about when you have something here and it's falling down, right? So it's just mg, and it's something that stopping, something that is stopping in air to go, just to fall down, and that's just for now is a negative, obviously, because it's a stopping, and mg is really in direction, so it's positive, that's going to be negative. dB is just really how, depends on how heavy is your object, right? So this is a constant which is really depend on your density. Does it make sense by now? Is that fine? Yes. So what I'm going to do is just really say all of this thing is just going to be a differential equation of mg minus b times the velocity, b times the velocity, if you have had some air resistance, so if you don't have, okay? So that's just really what's happening if you have both of them at the same time, because the air resistance is stopping you, so that's a negative one, okay? So this is a differential equation. This is a differential equation that we can solve it. This is a differential equation that we can solve it. For now, we don't have any name for that, but later easily we can just call it some of this thing that we will learn today. So I'm going to say, if I just put this, how do I solve it? So I can just divide by m, divide by m, divide by m, and then I can just move it to the left side, or I can just say this is the entirely, this is entirely like over the 1. So this is going to be dv on top, and then divide by mg minus bv, mg minus bv, mg minus bv, and then dt. So divide both sides by dt, oh sorry, multiply both sides by dt, divide by m.
Could you scroll back up really quickly for the no air resistance?
Okay. So, oh, you're writing, sorry.
Yeah.
Okay. And then I have divided both sides by m.
You don't like the Sims. I like watching people play with them.
Okay.
Okay, thank you.
So this is my differential equation. This is my differential equation. This is my differential equation that I can solve it by integrate both sides. Somebody needs, I don't see here, needs to mute. Who is on mute? Hey guys, you made it? Yeah, thank you. Now I'm fine, it seems. Everyone is muted. Okay, so that's fine. It's okay, don't worry. But if you have had something to share, or just unmute yourself. If you don't, so just mute yourself. Thank you. Okay, so this is what we can solve by integrate both sides, right? So I have a integration of dv mg minus bv, and this is, remember, these are all constant. Okay, so this is constant, this is constant, this is constant. So that's easy integration because these are all constants. And then integration of this one. Okay, so then if I integrate, if I use the u substitution of mg minus bv, so then du is going to be minus b dv. So this is natural log of denominator, and for the top I have to subtract because of this negative 1 over b. Am I right for my integration? Is that okay? Does it make sense? How did I integrate? And then here 1 over m is a constant. This side 1 over m is a constant. So then I just have dt, which is the integration is going to be t, right? And then plus the constant of integration, both sides. This is one technique that we want to practice for solving differential equation. Both sides have the constant of integration, but we know at the end we can add the constant and make it one single. That's why it's enough to put it either side, on right or left. So from now we make a contract, we always put the plus constant of integration from right side. One more time, what I'm trying to say, this side has a C1 constant of integration because you have done that definite integration, and this one has plus C2 constant of integration. I can subtract C1, and then I can call C2 minus C1 to be a C. Okay, so that's why it's enough to put one side this constant of integration. You don't need to put it in both sides. Okay. Okay, so if later you read this one, you can just follow what do I mean by C1, C2. So then the goal is, because this is solving for V, so the goal is, this is really complicated. What was unknown is really the V. You have to, your function of the V was just really what was just your unknown function or your variable. So you try to solve this whole equation by V, however you know, right? So however you know. So for example, I will multiply both sides by B. Okay, I will multiply both sides by B. So that makes me to have natural log of mg minus bv equals, this is negative bt over m, this is minus b times c, and then I can just e both sides because e by natural log cancel out. So that gives me mg minus bv on this side. This is e minus bt divided by m minus bc. Okay, and then mg minus bv equals e to the minus b divided by m. So remember, if you have a, for example, x plus y is the same as e times x, to the power of x. So this is the rule of algebra, okay? So I'm going to separate this piece by rule of the algebra, and that is just going to be something, okay? So this whole thing is a constant, okay? So it doesn't matter what is that constant. So e is a constant to the power of a constant is going to make a number. So that number, I'm going to call it something, okay? So the whole thing is going to call something, okay? So that's a constant. So that makes it nicer because mg minus bv equals a times e to the minus bt divided by m. And then, as I said, the goal is solving for m. Subtract mg, and then this is divided by b at the end, huh? So this is minus b equals mg plus a e to the minus b divided by tm. So then next step, divide by negative b, divide by negative b, and then divide by negative b. So I have v here, I have mg divided by b, and then I have minus, then I have minus a divided by b, e to the minus bt divided by m, okay? General solution. Any question about the algebra part? Is there any question about the algebra part? So that was the whole process. The whole process was to get or to solve for the v. Should I move on? Should I move on?
So for this general solution, was this just an example of how we could find velocity or v?
Yes, for this specific application problem, which is falling something down with the air resistance. Yeah. So that's
So
just,
when we were solving a problem, we could
yes.
just follow like a method like this to figure out what we need to find.
Okay, so think about this is a general solution. Why this is a general solution? Because of the constant of integration that we have had, right? So this constant of integration, so the whole thing that we have had, so that was a constant of, it was originally coming from the constant of integration. Since we have had that c, so then we got all these extra constant that we could just put it in one constant, okay? So then the question is, can I solve so velocity at the time t? That's a good question. Yeah, velocity at time t for the falling object. For the falling object, yeah. So can I solve for that constant? Which is just really the answer is it IVP? Does it have initial condition? Initial condition. So yes, then I can solve it for A. So when you have this, let me just put it in different color. When you have this constant here, so it's just for any A, because that constant here was for any A. So that means you can have thousands, and infinite many solutions for that A, because the constant of integration could be any other number, right? So that's why we call it general solution, because if that constant of C that we have had it right over here can be any number because of the constant of integration, because the derivative of constant is 0. So then that makes it infinite many solutions. So that's why it's called general solution. Okay. So, but then can I solve for A, or can I have it just really what we call a special solution? Yes, if you have IVP, if you have your initial value. So for example, so IVP of this, if your initial condition is given, so your just velocity at time 0 is given to be v naught. So then you have and differential equation. I'm going to copy from the top. So the differential equation that we have had originally from the top was m dv divide by dt equals mg minus bv. Okay, so that was the differential equation. Okay, so this is the initial condition, and this is initial condition, this is a differential equation. The total of this is going to be what we call IVP. So then that means just if I plug in v, if I plug in v at 0, that is mg divided by b minus a divided by b e to the 0. And then your goal is solve for my constant, right? So my constant is just right over there. I need to solve it for this, but again, some algebra steps. So algebra steps is going to be subtract mgb, and then that gives me v, oops, sorry, v naught minus mgb equals minus a divided by b, and then I have to multiply by negative b. I have to multiply by negative b, so that is going to be minus b v naught, and then b by b cancel out. Right over here, negative to negative is going to be positive. mg equals a. Fine? Did I mess up anything? Is it okay? Is it fine? My algebra is fine? Can I continue? My algebra is fine. So this was the original one. And then I had to plug in the t value. So this is the t value to be 0. So I plug in the t value to be 0. So that is going to be 1. And then I have to move this on the left side. And then I have to multiply by a b, and then I did multiply by the b. This is cancel out. Did I take care of negative? The first one is negative, the second one is positive. Okay, fine. So this is going to be the solution. So if you have had the solution at time t is going to be mgb minus a divided by b e to the, what was it, minus btm. So this is now mgb minus, okay, minus bv naught plus mg, and this is going to be all the way by b and e to the minus b tb. I have replaced. Is that fine? So that was my a, that was my a, that was my a. Okay, so I don't know whether it looks better or no, but that's just really the way that we could simplify. Negative inside, b by b cancel out, so I have m g and then b, which is negative. B by b cancel out, I have only v naught. Okay, and then bt divided by m. Okay, so this is simply showing the process of what we want to learn right now. Okay, so this is really saying if you have a initial condition, and then you have a differential equation that you could separate it. Okay, so then you can integrate, you can get the constant of integration, you can solve it, and that's just really what we call solution to the IVP, and that is really what is called later spatial solution. So this is again general solution because it has the constant. When you take care of your constant is called the special solution, or the solution to IVP is called the special solution. Okay, so this is it. Is there any question? I will say the nice thing about this type of equation, which I like it to discuss with later, you will see it in the application. So when the object is falling down is somewhere close to the earth, it makes sense because the gravity is just really 9.8, or just something is really like airplane, still it makes sense. But if when it goes further, when it's just really by time is approaching to infinity, this is really what you've seen in physics, right? So velocity then in this case, when time is approaching to infinity for this specific type of question, which is following the object, that's just going to be this piece, because as we know, e to the negative infinity is 0, right? So then this piece, the whole piece is going to be 0, and that's just really what's happening. And if you have had somewhere in physics, you've seen it, this one, but you will see in your homework too. That's why I'm just providing this formula. If it's the problem somewhere, some part it asks you what happened for falling. But if you have a t approaching to infinity, and that's what's happening, you are missing that t parts because e to the negative infinity is approaching to the 0. Sorry, this is not the right way to write it. Is approaching to the 0. Yes. Okay. Any question about this one? This is just the first introduction section of my chapter 2, which is just simply Newton's second law. Okay. If you have any question, let me know. If not, I'm just moving to the one simple differential equation, which we call it separable differential equation. And basically we have done this one right now by practicing that application problem. So separable differential equation is the simplest way of having differential equation by simply separate them. That's it. Simply, if you can separate these differential equation, you can integrate both sides, and then you are done. The algebraic simplification is really the process after that. Is there any question before moving to one type of differential equation, or the first type of differential equation that's called separable differential equation? Is that fine? Can I move on? Can I
Yeah,
move
we
on?
can move on.
Okay. So as you see, this is a separable differential equation. Simply means it's separable. So means if you have a y, it's sitting all on one side, and you have a x, it's sitting all one side. Okay. So your original one, it has dy dx, so it's y and x at the same time, y and x at the same time. But if you can separate, and whatever is in terms of x, put it on left side. It doesn't matter right or left. It's just really put whatever is in terms of x on right side, and then whatever is in terms of y on left side. So means you separate x's and y's. So how do you solve it? You just integrate both sides. So then left side is integration in terms of the y, and then right side is integration in terms of the x. Okay. So original problem has dy dx. So it has x and y at the same time. This is a function of f of xy. So it has x and y at the same time. The separable differential equation is an equation that can be written in separate. X is all on one side, y is on all one side. And that's just really what we call separate, or why we call them separable differential equation. How do we solve it? We simply separate them and then integrate both sides. And that's it. Okay, so that's exactly what we have done in previous problem. Okay, we separate it. So let me just go back one more time to tell you we have done this process in this problem. Okay, so I'm right over here. So this is just my original differential equation. This is my original differential equation was right over here. So this is the differential equation. So this is the differential equation right over here. and then I have separate them. This process that we divided an algebra, so I have separate all in terms of the v on here and all in terms of the t on here. Okay, so it's always one what you call dependent variable, one what you call independent variable. So there are two of them, v, which is in terms of the t. So t is one variable moving all on right side, v is the other variable moving on left side, and then you integrate both sides in terms of whatever you have. So here I have had v, so I'm integrating in terms of v. Here I have had t, so I'm integrating in terms of the t. Okay, so this is basically an example of separable differential equation. So I'm moving back to where I was, and that was just basically what we want to do with a few examples. Okay, so move on to the examples, the fun one. Okay, so this is going to be separable. How do I know this is separable? If I can separate them, that's it, right? So you can't see the problem and just guess unless you start to separate them to see whether you can separate them or not. Okay, so for a few problems, we just show the algebra because we are online. So just make sure we can follow what we are going to move. If I need to multiply both sides by y square for this one, so then I will write my steps. So this is y square dy dx, and this is x minus 5. Y square by y square cancel out. I don't need to write the y square. So then y square by y square cancel out. So then the next step, I multiply both sides by dx. I multiply both sides by dx. So then that tells me I have separate the y's to be all on the left side, and then x's to be on the right side. So this is that's exactly what I need to call this one separable. Okay, so then since this is a separable, how do we solve? It's basically integrate both sides, and that's it, both sides. Okay, so then if I start to integrate, this is integrate this side. I was going to choose a different color. So this is going to be integrate this side, and that's just really simple integration, right? So it's y cubed divided by 3. So this is going to be x squared divided by 2. This is 5x. And then I have constant of integration only on one side. Okay, constant of integration only on one side. Remember, because I will say solve for y, I meant really in dependent variable.
Wouldn't our
Okay,
constants cancel out?
of which one? How does it cancel out?
Because they both have a constant added to it. So I mean, would
So
we just,
that's a
or is
good
it not
question.
safe?
Yeah, that's a good question. Last time I explained, I can just explain a few more times because that's just really something we need to make sure makes sense for us. So remember, when you have had constant of this side, so this is just, maybe I like to make it some other color because I have to erase it. So so this is going to be a constant of integration on this side, which is plus C1, and another constant of integration on the other side, plus C2. The problem is C1, C2 are not the same. Okay, so they are not the same to cancel them out. So what is happening here, you have minus C1 on the left side, and then you have minus C1 on the right side. So then you called C2 minus C1 to be a capital C. So that's what you see, one side constant of integration, but they don't cancel out because imagine if you have had, so y cubed divided by 3 plus 5, and then you have had y cubed divided by 3 plus 10, And then if you take the derivative of both of them, for both of them is just really going to be y squared, is going to be y squared, right? So that constant are different. So then they don't cancel out. So they stays there, but it's enough to keep it on one side because the constants are add up to make one single constant. Does it make sense?
Yeah, that makes sense.
Okay, Marcos, was it the question or it was, I think it was complimentary. You said something to me.
Yeah, it was just a comment, but you beat me to it. So.
Oh yeah, okay. So then, so does it make sense why we are solving for y? Because that's just really what is the solution, right? So this differential equation has a solution. The name of solution is y in terms of, sorry, x. Y in terms of x, right? So that's just really what the question asked me to do, find or solve this solution. So I have to get the y. So then I need to do a little bit algebra over here. So multiply by 3 both sides. Multiply by 3 both sides and cube root both sides. Do you mind if I call my C this time? Just, I prefer the other color. Where was it? So to call something, okay? So that's a constant, right? If you just have them as a C and then 3 times of C is just really another constant. If you don't like, you can call it C1. But the thing is, this is just really a number. I don't care what's, sorry, it was just too down. I have to move it up. So I don't care what's the exact constant. Okay, so as long as it's a constant, you can just combine all type of constant together and put one constant there. Okay, so is it 3 times of a constant, 1,000 times of a constant, divide by a number? So however is in terms of the constant, you can combine all addition, division, multiplication of the numbers and call it 1C at the end. That's just the most simplified answer for this part. Okay. Any question? Any question for this one? Move on. Give me the time. Should I give you a break? It's almost time for the break. So do you?
Would we call that the general solution for this?
Yes.
Okay.
Thank you for reminding me. This is general solution. Why is a general solution? Because of that constant has infinite many possibilities. So that's why it's called general solution. And then if it was IVP, you can solve it for that constant, which we'll do today. Okay. Any other question? Okay, so let's have a few minutes break. It doesn't mean I go anywhere, so I'm here. You can ask your question.
Minutes?
I will say 7 minutes. Is that fine? So we'll start at 12:02.
That sounds good.
Okay. And I'll put it right over here if anyone is writing who is behind. But anyway, I will post this one. My lecture notes is on my hand. I can always post it to you. But that recording video, it's just really tough. I don't know, because it takes time to get it. And it's just really a lot of time for me to spend to, again, convert it, put it on YouTube. But as soon as I get them, I will make them available for you. So far, how do you like this type of classes? Is it? Yeah, that's just one of the advantage. Yeah, for me, as instructor, for the part that I had to just move all my setting and change my setting, was a lot of time. Because I had to always set everything at the beginning of semester, then at the end, and then I won't have time during the semester to go back and setting my weekly schedule or just seeing what is just going to do in this week. There was a lot of time to go back and just change all those settings, because basically that's 2 weeks work for me at the beginning of semester to set my entire semester. But after all, if I can just get back and then set everything, I think I'm just really doing the same thing. So the only difference between, I mean, as Derek says, we sleep more, and that's not good for health. We sleep too much. And then the other thing is, I have to sit down all the way for the class, unless I just start to do on the board, which just another problem is just the voice is coming as we have kids at home. But as far as the teaching, I think for me is really nice and almost the same. Almost the same, except I have to sit. There I was standing. I will call this one is type of, I mean, there's somehow a revolution in entire educational system. So I see in the future this type of classes, which is virtual classes, versus the online, fully online classes, versus the in-face classes. This should be some ideas of changes in educational system, and that's just really saving money for them, because that's just really everything on the teacher side and the student side, and what they are providing is just really the platform, which is great platform. I mean, the Zoom, the Blackboard, all this communication that they're spending a lot of money now is really what they are using that fact. So they have had really a lot of money for just make the Blackboard available for the students, all those systems and education is training. Now they are just getting the benefits of those money right away. They could switch every classes to the Blackboard, and they could just set everything in a day. I mean, the day after this thing happened and we had to stuck in our houses, the day after I have had class, and I could make my class right away without any worriness. It's just really what happened for my students, because as long as you have your phone on your hand, as long as you can do your selfies, you can do your classes too, because that's all is through your camera on your phones. And I think this is another advantage. At least we have something to do at home. Now we're starting at home, so it's something to do. Okay, here we are. So as I said, I have just several examples to try the separable differential equation, which is the very basic one. Okay, so this is very basic one because as long as I can separate them, I can solve them. That's it. Okay, so this is another one. And how do I solve it? I have to separate the y's and x's. So then this means if I just rewrite it over here, dy over dx equals k times y. So then I can divide both sides by y, and then that gives me dy dx equals k times, and then I can multiply dx. I don't think we need to write really this much a step later. Okay, so this is just we are practicing. So then I can integrate both sides. I can integrate both sides because I have already separated them. So this is going to be a y, and this is going to be k times x, and plus possible constant of integration, and that's it. Should I do?
You still have the 1 over y on the left side.
Oopsie. Yeah. Thank you. Why I left my y over here? My y over here. So that changes this one, huh? So this is natural log of y. Thank you. This is natural log of y. Yeah. Okay. So then if I want to solve for y, that would be e both sides. And this is going to be e to the natural log of y, e to the kx plus c. So this is y, which we want to be in this form because y is a function of x. Kx, one more time to remind you, this is the rule of algebra that says I can separate this thing. This is going to be e to the c, which we call the e to the c again to be a constant. Okay, so if you wish, you can call it c1. If not, you can just really keep it at c. You can keep it at x, I mean a, whatever else you want to call it. So that is just really y equals c1 and then e to the kx. Okay, c1 e to the kx, and that's its solution. Again, that's a general solution. To be exact, that's a general solution. Okay, and some of you might say, okay, I've seen this one in somewhere in calculus classes. I could really integrate here because this is so simple. And then I say derivative by integration cancel out, and that is just really k. And that's a question. Do I integrate in terms of x, or I do it in terms of the y? So that's just really what you don't know, right? So if you're doing in terms of the x, you're doing in terms of the x, so this is just a constant, and that's just really x. That doesn't make sense, right? Do you see what's the problem? That doesn't work. Okay, I'm going to erase this one. So separable must be separate first, and then integrate both sides. Okay. Any question for this example? Do you have any question for this example? No? Fine. Okay, so the IVP is just really another separable differential equation. The only thing is I have, sorry, press too much window. Okay, so the only thing is I have to take care of that constant. There is a way to find that constant at the end because of this initial value. Because of this initial value, you need to take care of your constant at the end and get particular or special solution, particular or special solution. So ready? Should I give you a little bit time to think about the problem?
We can just move on.
Okay, so then I have dy over dx. This is y minus 1 and then x plus 3. So you can multiply dx both sides, and then you can divide by y minus 1. You can divide by y minus 1 both sides. So this is going to be dy divided by y minus 1. This is going to be dx divided by x plus 3. And then integrate both sides because now is separated completely. So this is a separable one. And then you can integrate both sides. So integrate both sides. So that gives you natural log of denominator. That gives you natural log of denominator plus possible constant of integration. Plus possible constant of integration. So then since we need to solve for y, you can just e both sides to bring the y out. So one more time, so your goal is solve for what you have as a solution, because the differential equation is a function. The solutions of this differential equation is yx, right? So this is just really what I'm looking for. So then you need to solve for y. So means, what is it? E both sides first to get rid of that natural log. So e natural log of y minus 1 equals e natural log of x plus 3 e to the c, for the same rule of algebra, for product rule. So then e by e cancel out, so that is going to be only y minus 1, and this is going to be x plus 3, and then one more time you can call entire this one to be something, to be a constant. So to be a constant, I'll call it c1. Okay, so then what's the next step? I can plug in the value, get the c1. So that's just really, it doesn't matter where you do this one. So for example here, as you see, it says y at -1 equals 0, means if you have x value equals -1, the y value is 0. So the point of -1, point of -1, 0 is on graph of solutions, the general solution. Okay, so this is setting y to be 0, x to be -1. Okay, so what's the constant? -1, magnitude of -1 is +1, 3 minus 1 is 2, c1. So this is going to be c1 equals 1/2. c1 equals 1/2. So then y minus 1 equals 1/2 of x plus 3. Is it okay? If you have had some condition on your original problem, so you might say this is 1/2 of x plus 3/2 minus 1 on the right side is going to be +1. So then this is going to be nicely your particular solution. What is 3/2? So it's 5/2. Okay. I will stop here. And my reason is I'm not sure whether these y's are enough big, or is just really less than -1 to make this one positive absolute value. So I really prefer this form of solutions. Okay, but if you continue and get this one, I don't call you wrong, but this is more safe for me because I'm not sure which one is positive, or how big is my y and x's, unless the problem initially asks me the limits of your domain and range. And what is particular solution to IVP? Any question? Any question? Should I give you more time to write down, or you are fine?
Do you think for the homework they're gonna want us to go all the way and like solve for y and isolate it?
It depends on the problem, as I said. If initially somewhere in the problem says, for example, x is positive, y is positive, so yes, right? But here, since I don't know, it's just really this way. Okay, that would be enough. Makes sense? So solve the differential equation. Since this section is separable, we know all of them supposed to be separated. If not, I don't know how to solve it, at least as of now. But later, because we will learn 4 more types of differential equations, so then it makes sense to just think about whether it's separable or it's linear or it's homogeneous, and then exact, then you can just decide or change it to different types. But here it's just really clear. So which somehow you need to separate them. Okay, so for this one, you need to separate them. If it is not separable, so then for now at least I don't know how to solve it. Okay, but later you might. So I'm going to first move on the x minus 4 y to the 4th on right side, and then what I need to do is multiply both sides by
For a
the
while,
x. Okay.
and I was like,
One more. What was your idea? Y4 must simplify from right side because it has to be on left side. What else?
Doesn't it have to be negative?
Did I miss up the
It's
negative?
like
Thank you, thank you. This is negative. Or I can say negative by negative cancel out, but not now. Right, so I will do it in next step. Okay. Then I have what else to get rid of from this side. This is x cube, and this is x cube. I think we are done, right? All right, so I think we are okay now. So I have left only y square minus 3 dy divide by y to the 4th on this side, because of this by this cancel out, this by this cancel out. And then on this side, I have left with the x minus 4 divided by x cube, and then dx. One more time. This by this cancel out. Yeah, that's it. Okay. I have separate them. This is a separable differential equation. So this is a separable differential equation. And then the next step is just integrate both sides. Huh? So I'm going to integrate both sides. Then I can just do somehow simplification before that, because for integration, it seems I have to do this first. And then same over here, because I need to integrate, I have to separate this piece. And then that is going to be y squared I try to keep all the steps. If somehow, somewhere I'm skipping the steps, you have to remind me. So this is x squared, this is x cubed dx. Okay. So this is, what is it? Minus 1 over x squared, so it's minus 1 over y, right? No, I need to show you the steps, right? So that's y to the negative 2, and then I have to add 1, divide by negative 2 plus 1, because of y to the n dy is y to n plus 1 divided by n plus 1. Okay. Minus, this is 3, negative 4 plus 1, divided by negative 4 plus 1. The same thing over here. So this is x to the negative 2 plus 1 divided by negative 2 plus 1. This is x to the negative 3 plus 1 divided by negative 3 plus 1 plus possible constant of integration. So now I'm fine. Okay, so that's why it was this one. This negative 3 by negative 3 cancel out. So it's y cube. And then the same thing, minus 1 over x. And again, negative is by negative cancel out, 4 over 2, so it's 2. 4 over 2 is just 2. And then x to the second. This is it, huh? Plus possible constant of integration. And that's actually implicit solution, huh? So it's not really possible like the other problem that we have done explicitly in terms of, am I right? This has to be as it is because I cannot solve for y. So this is, if I call it the right way, is implicit solution. And still is general solution because it has the constant. Is it okay? So then again, if you have had the question whether I can solve it for y, it's possible you have to solve it. If it's not possible, you have to leave it, right? So this is not possible. That was an initial value problem. So this is the last thing we can do, okay? Is there any question?
So for an implicit solution, we just put in our explanation implicit, therefore y cannot be solved, so there exist no solutions.
Oh no, that's a solution. What's wrong with implicit solution? Implicit solution is a solution, right? So you remember in algebra, either you can just write y as a function of f of x. So that's what we call explicit solution. But you might have f of xy equals 0. This is what we call implicit solution, right? So it still is a solution. Implicit. Oopsie. I need to charge my battery. Right? Is that okay? Right? Again, explicit solution is a solution. Implicit solution is a solution too. So for one of them, you can solve it for y. For the other, or you can separate y all in terms of the x. For the other one, you just leave it as it is, which is fine. Okay. Any question? Let's just try to do another example, and that's IVP. Okay, so y at 0 is rad 3. So this is the other one. If it is separable, you can solve it. If it's not, you cannot. So you have to leave it. Okay. So this is example number 4. Now it's example number 5. Okay. Question? Move on.
Do you want us to try this on our own really quickly?
Yes, please.
Okay.
Okay. Can I have any of you? Was it easy to separate them?
It's easy to separate, but the integral's a little hard.
I saw a little bit more, I mean, reminding you about the
It's a special rule, right?
so which the left side is the okay integration of the left side. What's the left side?
Yeah.
The right side. I think the right side was the problem.
Natural
not
log
the
of secant x.
It's a natural log of the secant,
Yeah.
because I usually go by negative natural log of cosine, so that's just fine. It's really the same thing. Plus the constant of integration. Okay, so now plug in, right? So this value says if you plug in x value to be 0, the y value has to be at 3. So this is your x value equals 0. This is your y value equals at 3. So this is tangent inverse for the y, which is at 3, equals natural log of secant of the 0 plus c. The secant of the 0 is 1, natural log of the 1 is 0. So this is just really 0. So that is going to be c on left side, on right side, sorry, tangent inverse of rad 3. What's the tangent inverse of rad 3, guys? Are you with me?
Yeah, I'm just putting it in my calculator. Oh, in radians.
So
So what is it pi over 3?
pi over 6, no?
If it's root 3.
Root
It's not
3 is pi over 3. Yeah.
Yeah.
Okay. So this is my particular solution, right? So my particular solution, if I plug in right over here, is tan inverse of the y equals natural log of secant plus pi over 3. Okay, this is plus pi over 3. I can just write it nicer if I want. Okay, so that's just to practice the algebra. So for example, if the problem asks me to get the explicit solution for this one, is possible. It doesn't look nice if it just really look ugly, because you can just tan both sides, and that gives you y on the left side, and then tan of natural log of secant of x plus pi over 3. Okay, I think that's just really enough. But if it was just really more, we could continue by tangent of a plus b equals tangent of a times. I don't want you to go that much. Okay, so that was just really one rule that we have had in trig. If you're supposed to, I'm just writing here because this is just really one term and that's another thing. Don't just please distribute the tangent, because we don't have that distribution rule for tangent. I don't expect you to do that much. This is really perfect. You can stop it. But if you're supposed to do, that's just really long way. Okay, so that was a rule, which I don't expect you to do, but don't separate it. Okay, so leave it like that. Any question here? Any question here?
So like in terms of like our homework, we can expect to know like, or expect to see problems that want us to know these rules, but
No,
for like our
no.
exams,
I don't think, even for your homework, I don't think, no, that's not that much.
Okay.
No. This is just to remind you, because I have seen many students, they just say, okay, tangent of pi over 3, I already know is right 2, why not plug in right 2? Just to remind you, is not simply tangent of a plus b equals tangent of a plus tangent of b. It has a long rule. Okay, so don't do this one. You feel it looks better, but that's just using or skipping the rule. I am trying to do this problem just to practice. This is the last one for no. Are we okay right now, or?
I see your face. I don't see your screen. Oh. And I think you're muted as well.
Leave it up, leave it. Did you speak? Take up your chair. Good. Wait, Josh. Yes. I think 10 foot to what's there? It's still cool. What? You still have the iPhone cool. No, logo. No, I'm just saying, you still have it, right? Yeah. You randomly delete apps sometimes. Just I'm more super social media because like I'm on it for like 3 months. I'm off of it for like 2 years. Something like that. Last time I posted something on Instagram was 2018. Instagram was more consistent on in October or November. Big fish, big fish, big fish. Oh, I like that movie. Big fish. Make sure to say.
We still can hear you. You're still muted.